Take out on your own. All right, pay attention. There is a piecewise function says x plus 1. And there's x squared plus bx plus c. And this is a 1 less than x less than 3. And this is an x minus 2 greater than 1. Okay, so I am gonna look at this. So this is one of the questions that you guys have a hard time with, or going to have a hard time with, but it's not as hard as you think. So let's graph this on Desmos just for now. That way you get to see.
I know how to do it.
You know how to do this? Great. Okay, so this is one of the questions in there. So I am gonna go ahead and graph on Desmos and show you what happened. So if first of all x plus 1, and it's gonna have a restriction. Guys, please don't talk. Let me finish, and then you can talk. I'll try to finish as fast as I can. Because I don't want to talk over you. I don't have no energy to talk over you. Plus bx, so bx plus c, so plus c, and this is a thing, and that's gonna be absolute value. The restrictions absolute value of x minus 2, so x minus 2, and greater than 1, and you're gonna add a slider, and so there's a lot of thing going on here. So do you see there's a blue line, and I can play it. So there was only one chance, or maybe somehow that B and C is gonna be. Sorry, I'm gonna put a slider on both. So hopefully they will connect to each other, right? That's the idea, right? But the thing is, there's infinite amount of possibility. So pretty much that there is a gap at 1 and there's a gap at 3. So that is the main part of the gap. But then when we're gonna go back and do the problem is we're gonna start figure out, well, what is the restriction in this one? This will become a new algebra problem by itself. So I'm gonna say x minus 2 and greater than 1. I'm gonna say x minus 2 greater than 1, and x minus 2 is less than -1. And then that's going to be x is greater than 3 and x is less than 1. So x is less than 1 and x greater than 3 kind of makes sense because less than 1 and greater than 3. Do you see that blue line? It's going from greater than 3 and less than 1. Now I'm going to go in to say, okay, then I might want to write this in two different things. So I'm going to write the same thing that is less than 1. I'm going to say it's x squared plus bx plus c. And this is x is less than 1. Less equal to 1. And then this one is going to be greater than 3. Is that okay? So this is x greater than 3. So I write a two equation because that restrictions apply for both. So now I can see the issue happened at 1 and at 3. So what we can do is we can use limits approaching. And that's why I say on AP exam, please write down limits approaching. So it'll be limits as x approach to 1 on the left side. Which equation I'll be using? The first one or second one or third one? First one, so it'll be x squared plus bx plus c is equal to limit x approach to 1 from the right side on which equation? Second, good, x plus 1. So I'm going to plug in, so that's going to give you a 1 plus b plus c is equal to what? 1 plus 1 is what? It's 2, right? So b plus c is equal to 1. Is that okay? I minus 1 on both sides. I got to one equation. I use a limit. And on AP exam, you want to write limits. You cannot don't write the limits because you're approaching the value. Hopefully they connected. Now you're going to do the same thing on the other side. You're going to say limits x approach to 3 from the left of x squared plus b, from the right, sorry. I'm going to redo that again. So I'm going to say limits x approach to 3 from the left is going to be x plus 1, right? And it's equal to limit x approach 3 from the positive side, x squared plus bx plus c. Is that okay? Am I going too fast? 3 from the left side and 3 from the right side. You want them to connect it because that's the only way to make continuous. So 3 plus 1, direct substitution. You just plug in because it's not 0 over 0. It's going to be 3 plus 1. Is that okay? And that's equal to 3 squared plus 3b plus c. Am I going too fast? I'm going to simplify that. Don't be afraid of tediousness, because if you're afraid, you're not going to accomplish anything. So I can solve for this is equal to 3b plus c is equal to -5, right? I subtract 9 on both sides. Can I multiply this with -1? Is that okay? So if I do that, I'm going to get -b minus c equal to -1. So b2b is equal to -3. 2b is equal to -6. I can add. And the b is equal to -3. I find my b. Can I find my a? Well, I can plug it back in here. So it'll be -3 plus c is equal to 1. So plus 3 on both sides. C is equal to 4. Yes.
I'm confused. We wouldn't make it -5 over 3 is equal to b plus c, just like the other time. How we did.
No, I use system equation. I multiply this by negative, so I can use system equation, just like what you said before. You have 1 plus c and 1 minus c. If you add together, they will cancel.
So if we did it like that, where we made it -5 over 3 equals b plus c, it'd be wrong.
No, it will be more tedious. You have to deal with fractions.
Okay.
I don't want to deal with fraction. Here I didn't deal with any fractions. I do it in elimination rather than substitution. Now I'm going to say b equal to -3, c is equal to 4. b equal to -3, c is equal to 4. Look at this. How beautiful this is. But you got to start approaching slowly to think about all those things. And this is how you're thinking. For me, like, this is a question I shouldn't show you. I should go figure out on your own. Now, for you guys didn't understand what I was saying, you got to approach limits. The part is not a part is a breaking is a part that is between two restrictions. There was a gap. You can graph it first, looking at it. And by looking at it, you can know, well, I want to approach that value slowly. I want to approach this value slowly. And you got to pick the right equation. That's a hard part. Now, is this question on the test? Yes, it will be on the test. So it may be not the one with a restriction look like this, but you're going to have some type of restriction that's x greater than 2, x is less than 5. You're going to have something like this. And hopefully you understand this, and you guys can go back to talking. And do you have any questions? No?